got this attached here, and then you've got the C double bond O, and then it's attached to glutamate, right? And so, that's glutamate. Now notice, if we went back through, so what's this? It's flipped on its side, but here's our amino acid skeleton, right? We've got CH, C double bond O, and then NH. Now, if we were in this Witter ionic configuration, we would be in NH2+, because instead of the second H, like in Witter ion, we have NH3+, right? So if we pretend that this is NH2, instead of NH2, we have NH, and then all the rest of this. So this is actually literally glutamate. It's glutamic acid, okay? It's an amino acid that we're familiar with. We just have, instead of that second H, we've attached this whole extra part there. So that's the monoglutamate form, is folic acid. The polyglutamate form is this. It means you've got more of these, right? So when it says down here N, 5 to 8, it means that's repeated 5 to 8 times. That's tetrahydrofolate. So tetra is 4, hydro is water, and folate is the derivative of folic acid. None of that really matters for us, but it helps you recognize that here you've got this chain of glutamates instead of just one. And it's active for a bunch of different structural reasons, but so we fortify with folic acid. A lot of the supply that we take in our vitamins and minerals, like our supplements, is folic acid. Folate is usually the naturally occurring form, like our leafy greens, our orange juice, wherever you're getting your folate from, it's usually in folate form, and that means it can have numbers. Now, notice this is still folate. These are still folate derivatives. So it's possible to have a methyl group at N5. It's possible to have a methylene group between N5 and N10. It's possible to have a methanil group, which is CH and then a double bond between the C and something else at N5 or N10, or formyl or formamino. There are all these little permutations. It still stays, the root is still folic acid, so we still say it's in the folate group. We're not going to memorize the whole pathway where this goes to all these different ones, but in moving methyl groups, it's important. Like if we go back to, okay, so over here, the summary, so one carbon, so tetrahydrofolate is the enzymatically active form. So it can have 5 to 8 of those glutamates at the end. The 1 carbon units are added or subtracted at N5 and N10 positions. And I'm not going to make you draw this like I made you draw cholesterol. But if you go back and look at the picture, they've numbered, in this picture, all the different nitrogens, right? So you can go find, there's N5, right? And there's N10. So when it says there's a methyl group at the N5, it means that instead of the H there, it's NCH3. That's what that means, okay? Okay, so folic acid is the most stable form. This is synthetic. This is our supplement. It's monoglutamic, which means one glutamic acid residue, and it's fully oxidized. I'm not caring about the oxidized versus the reduced part. We're not going to follow this through and start counting stuff. This matters, okay? It's most stable. It's synthetic. We're making it and putting it in our supplements, and it's monoglutamic. Okay, so when I say figure 25.1, you should know the structure, right? And how to substitute it in N5 or an N10. In other words, you don't have to number that thing. I'll tell you what the numbers are. But if I say, instead of the H, find N5 and put a CH3 on there, put a methyl group, that you should know how to do. Or I could say, okay, at the N5 there's a change. It used to have an H, now it has a methyl group. What does that mean? It means that N5 was methylated. Okay?
We should know what the numbers are.
No, I'll give you the numbers.
Okay.
You just need to be able to recognize, like, find, and if I number them all, you
Right.
find the right one.
Okay.
Yeah, no, you don't have to. You just need to be able to recognize what the difference is between this and thiamine and niacin and riboflavin. And I will not be tricky. In other words, like, I will 90% give you this one, folic acid, because if I give you this one, and I go pull these from the internet in a non-copyrighted form, and if I give it to you in a long form, you're going to see this chain for like half the page of all these glutamic acid residues, and it can really confuse you. we're looking at these three pieces put together. It doesn't matter how many of these there are, it's still folate, right? Folic acid just has one, so don't get lost. Find the pieces. Find glutamate, find the benzene derivative ring, and find the tyrosine structure. If you can find those, I'm not going to make it difficult. I'm not trying to trick you into going, this is folate versus folic acid. No, I just want the big picture. Okay, this nomenclature, I don't